Hey, what's up, guys? Chung here again. And so today, let's take a look at this LeetCode problem here, number 967. Numbers with same consecutive differences. Okay, so you need to return all the non-negative integers of a length n and k. You're given like basically a length of n here, which means that's the answers for each of the integers. And another parameter is a k, which means every numbers every numbers in every numbers in the result, two different digits, the difference is exactly the k. And they ask you to return all the answers. I mean, you may return the answer in any order, basically. Okay. And the range is like only 1 to 9. Okay. So for example, this one, right? I mean, oh, one more exception is that any number starting with 0 will be a I mean, except for the 0 itself will be an invalid number. For example, the 0, 7, 0. For example, this one, that's an invalid number, right? That's why we don't have a 0, 7, 0 in this case. So, but one is fine, 2 is fine, right? So for 1, the next one has to be 8, okay? And for the 8, the next one is 1 because the range is like from 0 to 9, so it cannot be greater than that. And the second one is the 292 707 1 818 929. Okay, same thing for this one. So here, since the length is smaller and the k is even smaller, that's why we have a larger result set here. So I mean, this problem, I think it's a like very a classic like DFS search problem. So the way we should solve this problem is the basically we loop through all the numbers here, right? We loop through all numbers from 0 to 9, and we're gonna have like a DFS, or either DFS or a backtrack, because we will be like either inserting and removing. So I think either, okay, so let's do a DFS. And I mean, yeah, basically we just need to maintain the current numbers. We just need to maintain the current numbers here and on each of the state. So DFS is essentially basically by the time whenever the current numbers, the length of this is equal to k here, then we just add into the result set, and we just need to do a simple check to see if it's a valid number or not, right? Otherwise, we keep going it. What do? We check, right? With the current number here, I mean, this numbers, the last one, this array's -1 will be the previously number. For example, this one is the either 8 or something, and then we just need to check from this previously number. We just do a plus k and the minus k, and we check if this one is within the range of 0 to 9. Okay, if that's the case, we add it. We add it basically we do another DFS search. Else we just simply skip this branch. Okay, pretty standard classic DFS solution, right? And sure, okay, let's try to code these things up. Mm, I'm going to call it backtrack. I'll show you guys why I mean what do I mean to backtrack here. So basically, the answer set. Okay, and I'll also explain why I use set instead of list here. Okay, and then here the backtrack, right? So sorry. So here, right, we start from I in range 10, range 10, right? So we call backtrack I, okay, I, and we just basically try the all the numbers, and for each of numbers we will go through the backtrack method here. So if, right, if the length of current numbers, right, is equal to k, here we want to add this answer, right? We want to add this number here. So mm, but we want to convert it, right? Since the numbers we're storing in this like current numbers is the integer, we need to store convert it back to a um, so here's how I'm doing. I'm converting each numbers to a string, and then I'm converting it back to an integer here. So I'm doing int like string dot join. Here I'm converting everything to an integer here, to a string here. String number for number in current numbers. Okay, this join here. This one I'm converting it into a list here, and then I join that. Okay, but before doing that, we just need to do a simple check here, right? We need to know if it's an invalid number. So how do we know that? I mean, uh, and basically, if the so when do we add, right? So first thing is when the length of current numbers is zero. Sorry, is one. Okay, when this is one, I mean, we obviously will add it, right? Or what? Or the first element is not zero. Okay, then we add, right? Otherwise, we skip. Okay, so now we have a previously number, right, equals to now we just need to try all the branches here. Okay, it's gonna be -1. Okay, basically mm, if the previously number plus k, okay, is less than smaller than 9, right? Then we do what? We basically nums dot append, right? We append this number to the to this previous, we append that, okay? And then we do a backtrack current numbers. But after this, we need to remove it. We need to remove it. Basically, we need to pop it, right? So it's pretty straightforward, right? Because because here, I mean, after that, we have another case here. Basically, if the minus k, right, is greater equals than 0, then we need to do the same thing here. But we don't want this, since we're sharing the current numbers, is a list, it's a mutable list here. That's why every time we finish the first one, we have to pop the result so that the next branches will have a clean start, right? So, okay, and here is why I'm using a set here. In the case, in the case of k equals to 0, so what do we have here? We're gonna have like the pre-number plus k and the pre-number minus k will be the same value, which means we'll be processing the same current numbers twice, right, in the backtrack method. Since we don't want to duplicate it result, that's why I'm using a set. And this set will automatically remove the result, the duplicated result from me. Okay, so here I'm simply return the answer here. Mm, yeah, I think this should just work. Let's try to run it. Oh, sorry. Yeah. Return. Okay. Yeah. Anyway, so when we reach the length here, we should return it, no matter what. Mm, why I'm having this double number here? Did I? Okay. Goes to K. Oh, sorry, N. Not, yeah, not K, N here. Cool. Let's try to submit it. Yeah, it works. Okay, so yeah, it's very like a very classic like a DFS search, or you can call it backtrack because I'm using I append it and then I pop it out, right? So it's like a DFS plus the backtrack mechanism, and we just have a for loop here, and we loop through all the starting point here. That's the first step because we don't want to put the for loop inside, which is wrong, right? Because we want to start it for each of the starting point, we will explore all the possible branches, right? From the current state, which is the either we plus k or we minus k, and we check if it's a valid the state, and the next number is valid, and then we just keep going, okay, until we have reached the length of n. Then we check if this current number is a valid one or not. If it is, we simply add it, right, to the answer. Cool. I think that's pretty much it is what I want to talk about for this problem. Yeah. Thank you so much for watching the videos, guys, and stay tuned. See you guys soon. Bye bye.